Okay, welcome everyone. Let's start with our today's lecture. In the previous lecture, we have learned that stress is equal to load divided by the area. Therefore, the formula for the stress will be P, that will be the load divided by the cross-sectional area of that particular member, okay, which we are considering. Similarly, the strain is change in length divided by the original length. Therefore, the formula will be delta L divided by the original length of the member. As we know, the modulus of the elasticity is stress divided by strain, that is it is a constant, okay. So again other formula will be stress divided by strain, and the Poisson's ratio is lateral strain divided by the linear strain, okay. Now let's move forward to our next few numericals. Sorry, sim okay. We also learned that the delta L, that is the elongation or the compression between the member, will be equals to PL divided by A as per our particular formula, okay. By considering E is equal to, that is the modulus of elasticity is equal to total stress divided by strain. Calculating from that particular formula, delta will be equals to PL divided by A. Next, another factor, important factor, is the factor of safety, okay. Now we already know that the particular steel will fail at the maximum point at point some D, okay. That will be your ultimate stress where the particular steel is going to fail, and thereby it will not be able to carry any further loads, okay. Therefore, that particular ultimate load or ultimate stress is taken while calculating our particular load carrying capacity of the member, okay. But if you taken that particular quantity and design the particular structure, then it might fail earlier, okay, because we know that there are many accidental loads, okay, which might occur during the life of that particular building or the particular member. We cannot estimate how much exact quantity of the load that is going to apply to that particular member, okay. So for that we consider a certain extra factor, okay, so that that particular load will be able to carry a extra load within the safety limits, okay. So that if there is any other accidental loads are on this particular member, still it will be able to carry that particular load. So that factor is known as the factor of safety. Therefore, what are the ultimate stress is, we divide that particular ultimate stress with the factor of the safety, that will give us the working stress, okay. Working stress means the safety factor which we are going to consider while calculating the load carrying capacity of the particular member, okay. So remember that working stress will be ultimate stress divided by the factor of safety, or factor of safety will be equals to the ultimate stress divided by the working stress, okay. So remember this particular formula also. For steel we take the factor of, so generally for steel we could take the factor of safety as 1.85 meter, whereas for the concrete the factor of safety will be 3, okay. You already know why the lower factor of safety for steel and higher for the concrete. The concrete will be made at the site, okay, whereas the steel fabrication will be done at the industry, okay. Therefore for the steel the quality control will be way much higher. Therefore whatever the load, whatever the stress we are considering for that particular structure will be attained by that particular steel, okay, as it is fabricated at the particular industry. Whereas maximum time concrete will be fabricated or the casted at the site, okay. Therefore the quality control will not be, or quality control and quality assurance will not be up to the marks. Therefore that particular concrete may or may not be able to attain its ultimate strength, okay. Therefore in concrete we take the factor of safety 3, whereas for the steel we take it as a less than, okay, factor of safety, okay. Now the ductile material malleability हे तुम्ही वाचून घ्या, okay. Brittle material, that has a simple methods, okay. Next is the elastic constant. Elastic constant. First, obviously, modulus of the elasticity or Young's modulus, as we know by the Hooke's formula. Sorry, by the Hooke's formula, up to the proportional limit, the stress will be the stress will be, sorry. As per the particular Hooke's law formula, the stress will be directly proportional to the strain up to the proportionality limit. Therefore, as per the Hooke's law, the ratio of the linear stress divided by the linear stress divided by the linear strains will be equals to the E, and E is your Young's modulus of the elasticity. Okay, modulus of the rigidity and modulus of the and bulk models we will see this particular later. Okay, जब अपन example घेऊ त्याच्यावर घेणार. Next is a Poisson's ratio. We are discuss this particular Poisson's ratio. Okay, mu equals to lateral strain divided by the linear strain. Okay, बाकी okay, okay, let's see the numericals. Okay. So this type of the numericals might be asked to you in the exam, okay, either for the 4 marks or the 6 marks. Okay, जे काही तुमचे details असतात तुमचे depending varying sections, okay, varying cross section. In that case the particular question will be asked for the higher marks, whereas for the general section where you have to only calculate the elongation or the stress strain in that particular member, in that case it might be asked for the 4 marks. Okay, so it depend upon the length of the particular numerical. Okay, so first numerical. A rod is 25 mm in diameter and 2 meter long. The rod is subjected to the axial pull of a 40 kilonewton. Find the intensity of the stress, the strain, and the elongation. First, and the value of the Young's modulus should be taken as a 2.1 2.1 multiplied by 10 raised to 5 MPa or Newton per mm square. Okay. Now first we have to calculate the intensity of the stress. Okay, we already know that the stress equals to, that is sigma equals to P divided by A. We have P is given as, that is the load is given as a 40 kilonewton, and area is also given, not given, area, the diameter of the particular rod is given, therefore by particular diameter we can easily calculate the area of the particular section. So first we can easily calculate stress. Second, to calculate the strain, we have to find the delta L, that is a change in length divided by the original length. Now here we have original length, but we do not have the change in length. Whatever the elongation of the particular bar is there, we do not have that particular value. So what we do? But we have the another formula where E, that is modulus of the elasticity, will be equals to sigma divided by the epsilon, किंवा stress divided by the strain. Okay, so we have the value of the E, that is modulus of the elasticity. From the previous example we are calculating the value of the sigma, that is stress, so we can easily calculate the value of the strain. Okay, similarly for the elongation we know that strain will be equals to delta L divided by L. Okay, now we have to find the delta L. So we have the value of the E, previously calculated value of the epsilon or the strain, multiplied by the length of that particular member. That will, you can easily calculate the delta L, that is the elongation of that particular bar. So this way we can easily calculate all of these particular 3 quantities. Okay, so let's calculate. Okay, another most important point while solving the particular numerical or any of the numerical of the sum is firstly convert all of the particular data, whatever the given data is, into the one single unit. Okay, means if the particular diameter is given in the mm, then length should be taken also in the meter, mm. Okay, or if you are converting the particular length, particular diameter of the bar in meter, then you can take the length also in the meter. Okay, remember that a single continuous flow ठेवायचा unit मध्ये. Okay, do not take the unit of the particular diameter unit mm मध्ये घ्यायचा आणि length unit meter मध्ये घ्यायचा असं नको करा. Okay, you can solve that way also, but जो काही तुमचा formula आहे, in that case you will also have to put up some modification in that particular formula. Okay, so firstly whatever the units are, convert whatever the details or whatever the given data is, convert that particular data in the single unit. Okay, so first diameter is 25 mm, and if possible convert that particular data in mm or Newton per mm square. Okay, Newton आणि mm मध्ये सर्व data convert करायचं if possible. Okay, do not go for the meter or the kilonewton. Okay, because it is quite easy for Newton per mm. Okay, Newton and mm मध्ये केलं तर most easy जाते. Okay, so first D, diameter is 25 mm. Okay, so we are considering the mm and Newton, therefore no need to convert that particular value. Next is length. Length is given as a 2 meter, therefore converting that particular length in the meter, we know that 1 meter equals to 1000 mm. Okay, so 2 multiplied by the 1000, that will give us the mm, that is length of the particular bar in the mm, that is 2000 mm. Okay, next P is given in the kilonewton, okay, that is 40 kilonewton. So they're again converting that particular P or load into the Newton, that is 40 multiplied by 10 raised to 3, that is 40,000 Newton. Okay. Similarly, modulus of the elasticity is given in MPa. Okay, so that's a conversion. MPa equals to Newton per mm square. Remember this particular point. Okay, काही वेळेस तुम्हाला GPA मध्ये सुद्धा दिलेलं असेल. Okay, so just remember how to convert that particular point. Okay, so to convert GPA from the MPa, okay, 10 raised to 3 तुम्हाला multiply करायचं. Okay, so here as the MPa equals Newton per mm square, so we do not need to calculate that particular value. Okay, it will be 2.1 multiplied by 10 raised to 5 or to the 10,000 Newton per mm square. Okay, so first calculating the area of the particular cross-sectional area of the particular section. Okay, now the particular bar is a round bar. Okay, circular bar hai tumcha. Okay, therefore the formula will be pi by 4 multiplied by d squared, where d is a 25 mm, that is diameter of the bar. So pi by 4 multiplied by d square, that is 25 square. That will give us the quantity, area of the particular cross section. That will be 490.87 mm square. Okay, now for the calculation of the stress, the intensity of stress will be P divided by A. We have the value of the P as 40 kilonewton or 40,000 Newton, and value of the A as a 490.87 mm. So P, that is 40 multiplied by 10 raised to 3 Newton, divided by the area 490.87. that will give us the intensity of the stress. Okay, similarly the strain will be whatever the stress is divided by the area. Okay, so stress we have the whatever the stress is divided by the E, that is the Young's modulus. Okay, Young's modulus is 2.1 multiplied by 10 raised to 5. Similarly, the elongation will be whatever the strain is multiplied by the original length of that particular building, particular member. Original length will be the 2000 mm. Okay, so calculate the all of this particular values and put up in the message. Okay, chat box मध्ये put up kara intensity of the stress, strain, and also the elongation of this particular bar. Okay, put up the value and calculate that particular value. Understand the how we are calculating the intensity of stress, strain, and elongation. So first, calculating intensity of the stress P divided by A. P value of the P is 40 multiplied by 10 raised to 3 Newton, divided by the area mm square. So obviously that will give us the unit in the Newton per mm square. Okay, so whatever the load is divided by the area, that will give us the intensity of a stress as a 81.48. okay, 81.48 or 81.49 Newton per mm square. Okay, similarly putting that particular value in the stress to calculate the strain, that is 81.49 divided by the Young's modulus 2.1 multiplied by 10 raised to 5. that will give us the value of the strain. As we already know, strain, the formula for the strain is delta L divided by L. Okay, that is the unit of delta L will be in meter, so the unit of the total length will be in meter. Therefore the strain will have no unit. Okay, unit प्रत्येकाचा देत चला. For the stress, the unit will be Newton per mm square, or Newton per meter square will be there, or kilonewton per mm square will be there. Okay, whereas for the strain there will be no unit, as we are for the strain इथं आता तुमचं calculation काय आहे? For the stress the unit is Newton per mm square. Okay, similarly for the E, that is the Young's modulus, the unit is also taken as a Newton per mm square. Okay, so both of them will be deducted, therefore no unit for the strain. So for the strain, the value will be 0.0038. Okay, putting that particular value in the particular formula will give us the strain multiplied by the original length, that will give us the elongation in the mm. Okay, now if we have take up that particular value in the meter. Okay, समजा तुम्ही इतर सर्व मीटर मध्ये calculations केले असतील. Okay, in that case we might have to calculate that particular quantity in the we will get the quantity in meter. Okay, इथं जर तुम्ही particular quantity 2000 चा ऐवजी meter जर तुम्ही insert केलं, then it will give us the particular quantity in the meter. So whenever you are putting that particular value, okay, जे काही तुम्ही unit घेत असाल त्यानुसार तुमची particular calculation आहे. Therefore this particular unit, that is 0.76 mm, this is most important. Okay, इथं जर तुम्ही फक्त 0.76 आन्सर लिहिला आणि त्याच्या पुढे युनिट लिहिलं नाही, then it will be given as 0 marks. Okay, cause that particular unit is most important. What is this particular value, whether it is in mm, whether it is in centimeter, okay, or whether it is in a meter. Okay, similarly unit, all of the value you are calculating, such as the stress, okay, stress or the strain, in that case the unit is most important. Whatever the unit you are putting, that is the most important to verify your particular answer. Okay, next is a hollow column has to carry an axial load of 200 kilonewton. If the external diameter of the column is 25 centimeter, find the internal diameter. Take the ultimate stress of the real column to be 470 Newton per mm square, and allow a load factor of the 4. Now here we have to calculate the internal diameter of the particular column, so that the ultimate stress will be 470 Newton per mm square. Okay, now we already know that stress can be calculated, stress will be equals to P divided by A. Okay, we have the value of the P, that is 200 kilonewton. We will have the value of the stress. Okay, then we can easily calculate the area. Okay, here we have to calculate the internal diameter. Okay, so area of the particular bar will be pi by 4, whatever the external diameter is, that square minus internal diameter square. Okay, so if we find out the particular area, we have the external diameter. Okay, so we can easily calculate the internal diameter. Okay, now here for taking the value of the stress, where stress is stress equals to P divided by A. Now this particular value should be working stress, that is the safe stress. Okay, by considering the factor of safety, we cannot take the value of the ultimate stress. Okay, because if there is any other accidental loading will be there, then the particular column will fail. Okay, so accommodate for that particular extra or accidental loadings, we are going to take the value of the stress as a safe stress. Okay, so for that the factor of safety should be given. So factor of safety ला आपण load factor सुद्धा म्हणतो. So here the ultimate stress is given as a 470 Newton per mm square, and the load factor is given as a 4. Therefore the safe stress will be whatever the ultimate stress is divided by the factor of safety. Here the ultimate stress is 470 Newton per mm square divided by the factor of safety. Factor of safety is 4. Therefore we can easily calculate the we can easily calculate the total safe stress, okay, that will be 470 divided by 4, that will give us a safe stress as 117.5 Newton per mm square. Okay, so we get the value of the sigma, we also have the value of the P, so we can easily find the sectional area required. Okay, value of the sigma, sectional area required, will be load divided by the stress. Okay, load divided by the stress, load is 200 kilonewton. Okay, converting that into the Newton. Okay, so that we will get the particular value in the mm square. Okay, because we have calculated the safe stress in Newton per mm square. Okay, therefore unit conversion lakshat theva, okay, divided by 117.5, that will give us the value of the ultimate sectional area required as a 1702.12 mm square. Okay, now you can easily calculate, we have a value of the area also. Okay, so if the area of the particular bar will be pi by 4 divided by external diameter square, so pi by 4 multiplied by external diameter square minus internal diameter square. Okay, by putting up the particular value by the area value and as well as the d value, external diameter value, we can easily calculate the internal diameter value. Okay, so that particular value will be to 45.62 mm. Okay, so you got it, it is quite simple. सो दिस टाइप ऑफ द एक्झाम्पल, आता याच्यामध्ये वेगवेगळ्या टाईपचे तुम्हाला एक्झाम्पल विचारण्यात येऊ शकतात. ओके, एखाद्या वेळेस तुम्हाला सर फॅक्टर ऑफ सिट वगैरे दिलेलं असेल, तुम्हाला स्ट्रेस काढायला लागलं असेल. ओके, त्यावेळेस तुम्हाला स्ट्रेन काढायला लावतील, काही वेळेस तुम्हाला स्ट्रेन दिलेली असेल, फ्रॉम दॅट पर्टिक्युलर स्ट्रेन यू मे हॅव टू कॅल्क्युलेट द स्ट्रेस. ओके, तुम्हाला डेल्टा एल आणि एल दिलेला असेल, फ्रॉम दॅट पर्टिक्युलर डेल्टा एल यू कॅन कॅल्क्युलेट द स्ट्रेन. ओके, अँड देन फ्रॉम दॅट पर्टिक्युलर स्ट्रेन यू हॅव टू कॅल्क्युलेट द स्ट्रेस. ओके, सो सर वेगवेगळ्या टाईपचे या पर्टिक्युलर जे की तुमचे एक्झाम्पल्स आहेत त्याच्यावरती तुम्हाला वेगवेगळ्या प्रकारचे क्वेश्चन विचारण्यात येऊ शकतात. ओके, दिस टाइप ऑफ द एक्झाम्पल माइट बी आस्क फॉर द 3 or 4 मार्क्स. ओके, मॅक्सिमम, बट दिस हे या प्रकारचे क्वेश्चन तुम्हाला विचारण्यात आलेले आहे. सो जस्ट एक इग्नोर नको करा, सिंपल क्वेश्चन्स आहेत, तुमच्या आरामात होऊन जातात. ओके, नेक्स्ट इज elongation of the particular bar. Okay, now in this particular type of the section, okay, 3 new type of the numericals will be there. First type of the numerical will be the particular bar will have a certain length, the area, cross sectional area will be same throughout, uniform throughout the section, as well as the bar of the particular section. Okay, the kind of type of the bar will be or the metal of that particular bar will be same throughout the section. Okay, next is the diameter or the cross sectional area of the particular bar will be same throughout the section, but the material used for the particular bar will be different for the different sections. समजा suppose 1 असेल याला वेगळा, this is second, this is third. Okay, for first suppose इथे जसं ब्रास आहे तसं सेकंड साठी कॉपर, थर्ड साठी स्टील, किंवा दोनच सेक्शन असतील फक्त तुमचे, एकामध्ये कॉपर आणि एकामध्ये स्टील, अशा प्रकारचे you may have the different section. Okay, and the load will be applied. Okay, this is second, and third will be whether there will be a uniform section and it may have a number of sections. Okay, and that will be in the previous section the load will be constant. Okay, in this particular case the load will be different for the different section. Okay, जो काही तुमचा different section असेल त्याला different load दिला जाईल आणि you have to calculate the net load for that particular every section. Okay, now we have taken the combination of the all. Here the load will be different for the different section. Okay, याच्यामध्ये आपला जो काही load आहे that will be different. Okay, जो काही तुमचा समजा this is your section A B C D. Okay, for the section AB the load will be different at the different section. Okay, इथं P1, इथं तुमचा P2 परत इथं P3 आणि इथं P4 तुमचा अप्लाय झालेला आहे. Okay, as well as the diameter or the cross sectional area of the particular section is different. Okay, for the AB section it is 40 by 40, for the BC section it is 25 by 25, whereas for the CD section it is 30 by 30. As well as the here the metal or the material for that particular section will be different. Here first one is brass, second one is copper, and third one is steel. Okay, now to calculate the first we might have to we will ask for calculation of the stress only. or we have to also calculate the delta L, that is the elongation or the compression of that particular member. ओके, यापैकी कोणतेही एक विचारण्यात जाऊ शकते किंवा दोन्ही विचारण्यात येऊ शकतात. मॅक्झिमम वेळेस तुम्हाला डेल्टा एल फाइंड आउट करायलाच लावतील. ओके, सो इन दॅट केस फर्स्ट we can easily calculate the sigma by considering P divided by area. Okay, you have to consider the net load on this particular section, okay, divided by the cross sectional area. We can easily calculate the stress. From that particular stress, we can easily calculate the strain, that is sigma divided by the Young's modulus. Okay, and from that particular sigma, we can easily calculate delta L is equal to whatever the epsilon, that is the strain multiplied by the original length of that particular member. Okay, we can फक्त तुम्हाला load find out first. So first we have to calculate the load. Okay, from the load we can easily calculate the particular delta L. Okay, next thing is here the value of the E will be different for the different section. Okay, Young's modulus will be different depending upon the material. Okay, first suppose the material is brass, second is copper, and third is steel. Therefore we have to put the value of the various Young's modulus in that particular formula while calculating the strain. Okay, strain calculate करताना stress divided by strain आपण करतो, त्याच्यामध्ये तुम्हाला particular formula input करायचा आहे. Okay, in the previous section we already calculated the direct formula of the delta L by comparing the particular Hooke's law. By allowing the Hooke's law, that is delta L will be equals to PL upon A. Okay, so we can only use this particular single formula to calculate the particular value by inputting the respective value for the respective sections. Okay, so first let's see the numericals. A member ABCD is subject to the point loads P1, P2, P3, and P4. The loading is differential. Okay, the uniform loading is not there. Okay, different types of the loads will be applied at the different section. Okay, as shown in figure number okay, 10 okay, figure number कोणती पण असो. Calculate the force P3. Okay, for the equilibrium, if the P1 is 120 kilonewton, P2 is 200 kilonewton, P4 is 160 kilonewton. Now here the one load is not there. Okay, एक load जो काही असेल त्याची व्हॅल्यू तुम्हाला दिलेली नाहीये. Okay, in case of the example all of the load values will be there. Okay, P1, P2, P3, P4 सर्व load ची व्हॅल्यू दिलेली असेल. In some of the cases it may not be given. Okay, if it is there, okay, one of the value is missing, in that case you are going to apply a law of equilibrium to that particular section and thereby calculate the value of the whatever the missing section is or missing load value is. Okay, so calculate the force. We have to calculate first the force as well as the determine the net change in length of the member. Okay, now the important point is net change in length. Okay, now this particular every member will be subjected to the different loads. Okay, every section will be subjected to the different loads as well as every section will have the different value for the E, that is the Young's modulus. Therefore elongation by this particular load will be different for the different section. Okay, also there might be a compression of the section also. Okay, loading is differential, therefore only tensile strength may not be applied to all of the loads. For the certain section the compressive load may be applied. In that case the loading will be different. Okay, in that case the elongation will not be there, compression will be there. So we have to calculate the total elongation on the compression in this particular section. Okay, जे काही तुमचं elongation असेल त्याला प्लसचं साइन देऊ, जे काही तुमचं contraction असेल त्याला आपण मायनसचं साइन देऊ, and thereby we will calculate the total or the net change in length of that particular member by using formula delta L is equal to PL upon A. Okay, so the Young's modulus for the various materials are given. Okay, first section is of the brass, therefore Young's modulus of the brass is 1 multiplied by 10 raised to 5 MPa. For the copper it is 1.2 multiplied by 10 raised to 5, and for the steel is 2.1 multiplied by 10 raised to 5. Okay, megapascal, that is Newton per mm square. So first, by applying the laws of the equilibrium, we will resolve the particular forces. Okay, so therefore considering एक कोणतेही कन्वर्जन घ्यायचं. ओके, इधर लेफ्ट साइडला जात असलेले तुमचे पॉझिटिव्ह कन्सिडर करायचे आणि राईट साइडला जायचे निगेटिव्ह कन्सिडर करायचे, और व्हाईस वर्सा सुद्धा घेऊ शकता. लेफ्ट साइडचे निगेटिव्ह, ओके, अँड द राईट साइडचे पॉझिटिव्ह, व्हॉट एव्हर इट इज यू कॅन कोणताही तुम्ही घेऊ शकतात. ओके, दोघांपैकी कोणताही एक तुम्ही साइन कन्व्हेन्शन घेऊ शकतात thereby calculating the calculations. Okay, first we are going to solve that particular numericals from the left hand side. Okay, जर तुम्ही right hand ने solve करत असणार, in that case consider the loads, sorry, आपण left hand side ने solve करणार आहोत. Therefore the loads to the left hand side, whatever the loads are going to the left hand side will be positive, whereas the loads to the right hand side, okay, right hand side load towards the right hand side will be the negative. Okay, therefore P1 minus P2, okay, plus P3 minus P4. Okay, inputting the particular values. Okay, P1 is 120, P2 is 220, and the P4 is 160. Therefore value of the P3 will be 260 kilonewton. As the particular value is positive, okay, therefore the direction of the particular, again here the direction of the P3 is given. Okay, याच्यामध्ये तुम्हाला direction of the P3 is given, so you know that the value will be like this. Okay, the particular force will be like this, that is the value will be positive, as we are considering the force going to the particular direction, left hand side is positive. Okay, in some of the cases this particular direction might not be given. Okay, so what are the sign convention you are considered? From that particular sign convention you can calculate the value of the P3. Okay, whether it is a positive, whether it is a negative. Okay, maximum वेळेस तुम्हाला कन्व्हेन्शन दिलेलं असेल किंवा एखाद्या वेळेस नंबर ऑफ सेक्शन असेल, म्हणजे दोन सेक्शन मधून तुम्ही पर्टिक्युलर व्हॅल्यूज काढू शकतात. ओके, समजा व्हॅल्यू ऑफ द P1 and P4 is sorry, value of the P2 and P4 is way too higher compared to the P1. Therefore this particular P3 should be going this way by considering the equilibrium. Okay, अशा प्रकारचं लॉजिकल एक्सप्रेशन तुम्ही लावून कॅल्क्युलेट करू शकतात. ओके, so next, calculating the extension for the first section, that is AB section. Okay, now first the formula is quite simple, delta L. Okay, delta L equals to PL upon A. Now we have the value of the E, that is the Young's modulus. We also can calculate the value of the area. Rectangle square section is there, 40 mm by 40 mm, so we can easily calculate the area. We have the value of the length. Length is also given here, 0.75 mm. Okay, 1 meter. Okay, so we have a value of the L also. Okay, so we only have to calculate the value of the P. Okay, now to calculate the value of the P, always start at the one point. Okay, एक तो तुम्ही left hand side ने चालू करा किंवा right hand side ने चालू करा. Okay, whatever the side you are, you can calculate that particular quantity. Okay, suppose if you are calculating the particular from the left hand side, in that case जो काही तुमचा मेंबर असेल त्याच्या स्टार्ट जे काही असेल त्याच्या अलीकडे जे काही मेंबर्स असेल. ओके, व्हॉट आर द मेंबर्स विच आर फॉलोइंग ऑन द लेफ्ट हँड साइड ऑफ दॅट particular section should be considered while calculating the value of the P. Okay, now for first cross sectional, that is cross sectional AB, only one force is falling to the left hand side. Okay, जो काही तुमचा क्रॉस सेक्शन असेल, ओके, समजा हा तुमचा क्रॉस सेक्शन असेल त्याच्या लेफ्ट हँड साइडला. ओके, किंवा जर तुम्ही इथून घेत असाल राइट हँड साइडने, in that case, in this particular case we are going to calculate only the loads which are falling to this particular या लाईनच्या जे काही पुढे असतील. In suppose here it will be P4, here it will be the P1. Okay, so starting with the left hand side, okay, the loads that are on the left hand side of the particular section will be only one, that is P1. And as we are considering the sign convention also, that will be left hand side positive, okay, and the right hand side negative. As आपण sign convention consider केलेला. Okay, you can consider whatever you want. Okay, there is no point there. Okay, so first the P will be 120 kilonewton. Okay, only one force is there, and we know the value of the P as a 120 kilonewton. Okay, so again, as the value is the positive, therefore that particular in this particular section the load applied will be like this. आपल्याला माहिती आहे जे काही लेफ्ट हँड साइडला तुमचे लोड जात असेल that are positive. Okay, therefore the load applied on the section will be like this. Okay, P1 and the P2. Okay, ह्या मेंबरला कन्सिडर करा, त्याच्या अपोजिटला तुम्हाला इथं तोच लोड अप्लाय होणार. ओके, therefore in this particular case that particular AB section will be subjected to the tensile force. Okay, हा जो काही तुमचा particular subject आहे, that will be subject to the tensile force. Okay, therefore the AB will be extended. Okay, जो काही particular member असेल, that particular member will go through the extension of the length or the increase in length rather than the decrease in length. Okay, therefore taking the value as a positive, okay, that is PL upon A, value of the P is 120 kilonewton, converting that particular value in the Newton. All of the value are in Newton or mm, okay, or Newton per mm मध्ये आपण सर्व value consider करणार. Okay, the length is 0.75 mm, therefore 0.75 multiplied by 1000, okay, converting mm. Okay, the area is 40 by 40 and the Young's model is 1 multiplied by 10 raised to 5. By calculating the particular value, you can easily calculate the value of the extension in the particular AB, or the change in length of the AB, that is 0.5625 mm. Okay, delta L, or the change in length, is 0.25 mm. Okay, again this value is the positive value, means this particular value is the extension. Okay, now for the next section, okay, for the next section, okay, of the copper section. Okay, now here again considering the okay, sorry for that. Again, for that particular section, BC section. Okay, again for BC section, considering this particular left hand side section. Okay, now here at that particular section, one force is there, that is P2, and on the right on that particular section, one force is there, that is the P1. Okay, thereby calculating the value. Okay, P1 is positive as it is going to the left hand side, therefore the force on the particular BC will be equals to plus 120, that is P1 value, and this particular P2 is going to the right hand direction, that as per our sign convention it will be negative, therefore 120 minus 220, okay, that will give us the value of the P as negative minus 1000 kilonewton, means that particular force will be going to the left hand right hand side. Okay, so applying the same force in this particular on this particular section, in this particular on this particular section, and here again applying the opposite section. Okay, yacha opposite घ्यायचं. Okay, whatever the section is. Okay, if here the particular section loading is like this, then we are going to consider the opposite at this particular section. Okay, here the particular loading is towards the right, therefore again here considering the opposite, that is towards the left. Okay, as you can see, both of the loads will be of the compression type. Okay, of the therefore the change in length will be in the negative, or the particular member will be compressed. Okay, so while calculating the BC, the extension will not be there, the contraction of the BC section will be there. Okay, that as the particular force is negative, or the compression type force, therefore there will be a negative value, that is the BC. So therefore the delta L value will be negative, or that particular member will be contracted instead of the elongated. Okay, so again taking the value as a PL upon A, okay, value of the P is 100. Here the negative is there because the particular section is contracting, or the force is of the compression type. Okay, so putting that particular values, value of the E will be value of the value of the L, value of the P will be 100 multiplied by 10 raised to 3 Newton. Value of the L will be length is 1 meter. Area is 25 by 25 mm. And the particular Young's model is 1.2 multiplied by 10 raised to 5 EMPa. Okay, putting that particular values in the section will give us the quantity of the particular contraction of the BC, or the change in length of the BC. That particular change in length is negative, means that particular section is contracting, as the compressive force will be there. So the particular section is contracted, therefore the value of the particular delta L will be negative, that is minus 1.333 mm. Okay, similarly for the third section, force on the CD, again calculating the particular section CD, considering the particular section. Okay, left hand side of the section घ्यायचा. Here all of the particular values are, first it will be P1, next P2 left hand side value, and next it will be the P3. Okay, therefore the force on the CD will be 120. Okay, right hand side जाणार आपण पॉझिटिव्ह घेतलेला आहे, therefore plus 120. सॉरी लेफ्ट हँड साइडला जाणार आहे, राईट हँड साइडला जाणार आहे आपण निगेटिव्ह घेतलेला आहे, therefore minus 220, and P3 value again it is going to the left hand side, therefore positive. Okay, so 120, that is P1 value, minus 220, that is P2 value, plus 260, that is a P3 value. That will give us the total force on the particular CD as a positive 160 kilonewton. Okay, so the force on the particular section CD will be 160 kilonewton. Again, as the particular force is in positive section, okay, therefore the particular sign condition will be like this, the force will be applied like this, therefore it is a tensional type force. Okay, tension hai, therefore the particular CD will not contract, rather the it will extend. Okay, as the particular force the force is of the tensile nature. Okay, tensile nature. Okay, therefore the extension of the CD, again put in the particular formula PL upon A, we have the value of the P as a positive 160 multiplied by 10 raised to 3, as the particular value is of the tensile force. Okay, it is the tensile force. Okay, multiplying with the 1.2, that is the length of the particular member. Okay, 1.2 meter, dividing with the area, that is 30 mm by 30 mm, and the Young's modulus, that is 2.1 multiplied by 10 raised to 5. That will give us the extension of the particular CD. Okay, so now calculating the net change in length of the member. Okay, as per our particular calculation, first member is elongated, second member is contracted, and third member is elongated. Okay, therefore whatever the value is plus 5625, so net value will be elongation of that particular first member, that is plus 0.5625. Okay, next contraction of the particular second member, that is BC. Okay, so contraction will be represented in minus. Okay, so minus 1.333, 4 times 3, and again last section is again elongated, therefore plus 1.015. that will give us the net elongation or the net extension of that particular member, that is 0.245 mm. Okay, now this type of the numericals might be asked you for the 6 marks. Okay, याच्या टाइपचे एक्झाम्पल मॅक्सिमम तुम्हाला 6 मार्क्स साठी विचारण्यात जात असतात. मॅक्सिमम वेळेस दिस नंबर ऑफ सेक्शन विल बी 3च असतात, काही वेळेस तुम्हाला 4 किंवा 5 सेक्शन सुद्धा असू शकतात. ओके, so the loading will be different, and the material might be same. Okay, here the brass and the steel is there, some of the times only the brass and copper will be there, or only steel of particular section will be of the uniform material, that is steel, or a same material will be there, but the modulus of the elasticity will be different, as we know that for the steel. Okay, depending upon the different alloy, the modulus of the elasticity will be different. Okay, steel साठी जर तुमचं बघितलं, depending upon the carbon ratio, the modulus of elasticity will be different. So again, the same material will be there and the modulus of the elasticity will be different. Okay, काही वेळेस तुम्हाला फक्त modulus of the elasticity मेन्शन केलेली असेल, कोणत्या टाइपचं मटेरियल असेल, जे ब्रास वगैरे आहे, that is not mentioned in that particular numerical. Okay, you was only have to focus on the particular formula. Okay, the one thing is convert all of the particular values, while हा जो की तुमचा formula असेल PL upon A, while calculating that particular, putting the all of the value in that particular value in that particular formula should be of the same unit. Okay, same nature of the unit. Okay, if the particular force is taken in Newton, then all of the forces we should be taken in Newton. Okay, मीटर असेल तर मीटर मध्येच घ्यायचं. समजा आपला E ची व्हॅल्यू असेल MPa, in that case again the value is Newton per mm square. Okay, so if you are taking the E value in the Newton per mm square or the megapascal, in that case all of the other values such as the length or the force should be in the Newton or the mm. Okay, it is you can modify this particular formula while calculating the particular value, but still it's एकदा कन्फ्युजन टाळण्यासाठी तसंच करा. सर्वांचं जे युनिट आहे ते सिंगल नेचर मध्ये ठेवता, इतर न्यूटन मध्ये किंवा एमएम मध्ये. न्यूटन किलो न्यूटन मध्ये घेसा, किलो न्यूटन आणि मीटर मध्ये. ओके, किंवा न्यूटन आणि सेंटीमीटर मध्ये सुद्धा घेऊ शकता, किंवा न्यूटन आणि मीटर स्क्वेअर मध्ये सुद्धा घेऊ शकता. ओके, सो व्हॉट एव्हर यू आर टेकिंग, जस्ट युनिफॉर्म युनिट ठेवा. ओके. Next is your thermostasis. Okay, this for the particular members, okay, which are when the external load is applied to that particular member. Okay, now as we know that the particular matter is going to expand, and while when the particular, as the nature of the property of the material, when we are hitting that particular material, okay, समजा जो काही तुमचा material असेल, okay, suppose we have the bar of the particular steel. In that case, if we are hitting that particular member, okay, in that case it is going to expand. Okay, whereas if we are pulling that particular metal, in that case it is going to contract. Okay, so if we have a particular members which for that particular members, if the end of that particular members are hold together, okay, if the particular member जे काही तुमचे end असेल, they are fixed, so that there will be no elongation or the contraction of the material is allowed, or the elongation of the contraction of that particular member is not allowed. In that case, if we are going to hit this particular member, okay, it will try to elongate, but as the particular ends or the particular support, it's a fixed support, therefore it will do not allow any elongation. Therefore, as the elongation is restricted, that particular member, in that particular member, the stresses will occur, okay, as the elongation is extended. Okay, if we allow the free movement of that particular member, in that case the elongation will not be there. Okay, if that particular bar is left free to expand. Okay, but if the free expansion or the free contraction is prevented, then the thermal stresses, that is the stresses occurring due to the change in the temperature, will be there. Okay, so those are known as the thermostresses. Okay, thermostresses are the stresses which occur due to the change in the temperature of that particular bar, and where the particular bar is restricted from the elongation or the contraction or the free expansion or the elongation. Okay, so in that case the different type of, in that case we have to calculate this stress in that particular sorry, the stresses will occur in that particular member. Okay, now to the elongation or the contraction of that particular member can be calculated by formula delta L, that is a change in length, okay, is equal to alpha TL, where alpha will be the constant proportionality or the thermal constant म्हणता तुम्ही त्याला. Okay, the T will be the time. Okay, the time which for which that particular member is cool, or the it is exposed to the heat or the cooling nature. Okay, and the length is the original length of the member. Okay, again, so you can easily calculate the alpha, that is a coefficient of the thermal expansion. Okay, it will be given to you. We can calculate the length, and the time is given to you, so you can easily calculate the delta L. Okay, in some of the cases the particular bar will be left for the free expansion, okay, free to expand. So in that case you will also, you only have to calculate the delta L. Okay, whereas if the particular bar is prevented from the expansion, in that case, as the bar will not be able to extend, in that case the thermostasis will be developed. So we can easily calculate this thermostasis by inputting the particular delta L value. Okay, we have the formula of the delta L. Okay, stressचा formula तुम्हाला delta L equals to, we have the formula for the stress. Okay, Oakes law formula आपल्याकडे आहे delta L equals to PL upon A, and from this particular session we know that the delta L occurred due to the change in temperature will be alpha TL. Okay, so by comparing both of the particular value, we can easily calculate the stress which is going to occur. Okay, or also the thermal stress. Okay, now the numericals on this particular topic आपण याच्यानंतर घेऊ. Okay, this is your next topic. Okay, before that, the bars with the Also, the numerical simple numericals will be there, where the bars with the varying continuously varying section will be there. Means the diameter of the bar at the particular end it will be different, where the diameter of the bar at the other end will be different. Okay, so the cross section area of that particular bar will be we cannot take a uniform. Okay, therefore आपण जे काही PL upon AE आपण जो काही formula use केला, okay, we cannot apply that particular formula as the area of that particular section is not uniform. Okay, so in that case the next formula should be used. Okay, where delta L equals to 4PL upon pi modulus of the elasticity, and D1 multiplied by D2, where D1 are the diameter from the particular मेंबर्स. ओके, जो काही तुमचा स्टार्टिंगचा डायमीटर आणि एंडचा डायमीटर हा फॉर्म्युला फक्त लक्षात घ्या. न्यूमेरिकल काही चेंज होत नाही, फक्त तुमचा डेल्टा एल चा फॉर्म्युला चेंज होतो, बाकी ऑल ऑफ द न्यूमेरिकल्स विल बी सेम. ओनली हियर ॲज वी कॅनॉट टेक एरिया ॲज अ कॉन्स्टंट एरिया. ओके, देअरफॉर द जो काही तुमचा चेंजिंग एरिया असेल त्याचा फॉर्म्युला तुम्हाला अप्लाय करावा लागतो. सो ओनली रिमेंबर दिस पर्टिक्युलर फॉर्म्युला, नो change will be there. Okay, similarly elongation due to the self weight will be there. Okay, यावर तुम्हाला एक सिंगल न्यूमेरिकल सुद्धा विचारण्यात येऊ शकते. यापैकी आपण न्यूमेरिकल घेऊ वाटलं असेल एक. ओके, in that case the form elongation due to self weight will have the formula as a WL square upon T, that is delta L elongation due to the self weight will be WL square upon 2E, where W will be the self weight of that particular bar. Okay, we can easily calculate the W of the particular sorry, W will be the specific weight of that particular bar. Okay, multiplied by the length. Okay, that will give us the total weight of the bar. Okay, total weight of the bar divided by 2E. Okay, you can easily calculate the delta L, that is the elongation due to the self weight. Okay, for the formula लक्षात ठेवा. Okay, we will take the numericals on this particular formula. Okay, okay, that will be all for our today's lecture. Okay, in the next lecture we will take the numericals on the thermostasis. Okay, same the type of the numerical will be there. Okay, आपण जे आता numerical घेतलं याच प्रकारचे numericals आहेत. Suppose in this particular case this particular bar will be subjected to the force. Okay, त्याचे काही end असतील तुमचे ते restricted असतील. Okay, therefore you will have to calculate the stress form in this particular section. Okay, by applying the particular formula. Okay. Okay, then that will be all for today's lecture. You can leave this particular lecture. Thank you.
Hello.
Hello.
Hi. Hello. Hello.